Hello, what's up, what's new? This video I will demonstrate designing a rotor for a pulse motor and then printing it, 3D printing it. So to begin, we are at my homepage for TinkerCad, which is a wonderful program that's absolutely free. That makes it even better. So here are just things I've designed on here before, and so I have lots of fun with it. And we're going to do a new one, so I'm going to press New, 3D Design. This TinkerCad is the little brother of the paid program called Fusion 360, and I haven't explored probably a fifth of the capabilities of this free program, so I certainly am not going to worry about Fusion 360 unless I have learned more of what's going on with this. You can do an awful lot with this program, though. I watched a video of someone who had a picture of a lobster there, and then he built a 3D lobster. It was incredible. So I don't know how to do anything like that. I'm a novice at this, but a lot of you have probably never used TinkerCad, so that's fine as well. And further, I'm not trying to spin a lobster, am I? That would be kind of fun. That would make a nice conversation piece if your rotor was a lobster. But all I want is a well-balanced rotor, and so instead of getting a Dremel tool and trying to cut along a line or something like that, you can use this and then 3D print it, and you're accurate to sub-millimeter levels. And that's why I use it. That said, it's also just tremendous amounts of fun. You're just playing with blocks. So you go over here and you left click and you pull this in, and now you see we have a block here. And if we click here, this gives us the height of the block. If we click here, that's the width. So I've been using 4-inch rotors, so we're going to keep those. And so you go in there and say 4 inches, 4 inches. Now we have a 4-inch rotor. Before I forget, see here, you can kind of see the segments that it has, and that's sides on this pull down for our cylinder. And so I'm going to set that to the maximum, and that'll give us the smoothest cylinder. So now we have a 4-inch diameter rotor, and it's 1 inch high. If I right click on the mouse, then you can go on the work plane and look dimensions. So the next thing that we want to do is, this was the height of the previous rotors. We want to make that twice as high because we're going to have 2 rows of magnets instead of 1. So what's the first thing we should do with this cylinder so it can spin in a pulse motor? It needs to have a bearing, and the bearing needs a place to go. So now I can introduce the idea of holes, which are just like your blocks and cylinders before, except for they make a hole. And again, you just drag it in. So here we have a hole, and we're going to put this in the middle of here. How big should the hole be? Well, I use skateboard bearings. I don't know if that's what you're supposed to do, but that's what I use. So what are the bearings, what are the dimensions of skateboard bearings? And if we go to images here, we can see they're 22 millimeters. 22 millimeters. That's the standard. We're working in inches with our 4-inch rotors, so we want to know what 22 millimeters is in inches. So 0.866 142. Now I'm going to say 0.867 because we need to glue it in, and the glue should, I think that'll be good. I don't know. I mean, this is a bit of trial and error. 0.867. 0.867. We really want to remember to make the side 64 so that it has a good fit for the skateboard bearing. And now we want to make the height 2 inches. Now we want to line these two things up. So you take and left click and draw around the two. And now you go up here, and if you see this button, it says align. So we want to press that. And this is where this thing gets just so useful and fun. If we go down here, you can see that this now aligns it in that plane. This now aligns it in that plane. And if they were different heights, then you could align it up and down vertically. So now we have, and we can see it goes through. Now we have a hole perfectly in the middle. So what do you do next? Now you press this button called Group. Ta-da! See how it's kind of fun? What's the next thing we want to do? Next thing we want to do is to give ourselves a place to anchor the magnets. The magnets are 1 inch in diameter, 1/2 inch thick cylinders. So first let's just set this to 1/2 inch. And now set this to 1 inch. It's already there. So let's just make the sides again 64. I'll mention a couple other things. Is I wish that I had bought square magnets. Now that I'm doing a little bit of experimenting with this. The reason being that when I line these two rows of magnets up, if you don't have good magnetic coupling between the first and the second row, let's say they're both coming out towards you north facing, you get a artificial south if there's any space between the two. So I originally built one like this, and I said, well, you know, I'll give myself an 1/8 inch of space. You know, why worry about running into problems? And it absolutely stunk. And when I ran a Gauss meter over the magnets, I could see the polarity change in the middle. So then you're fighting against yourself because you have a north and then a, you know, the south comes there. What I am hoping is that if I have these things snug, there'll be enough of a magnetic path between the two that they will join and function as one magnet. Would I be more comfortable having square magnets where you're going to have definitely a good magnetic flux path? Yes. However, each one of these magnets, they used to be about 10 bucks and now I think they're like 12 or 15. So we're going to have 8 magnets there. You can do the math, you know, 8 times 12 is 96. So you're looking at about 100 bucks worth of magnets. Is getting a perfect magnetic flux path worth 100 bucks? I don't know yet. I mean, it might not be even an improvement if I had the square magnets once I get it set up. So a lot of this is trial and error. But you know, that could be like the window motor 1.1 is get the square magnets and make sure everything's flush with a good magnetic flux path and see if that improves. However, one thing I really like about these magnets that I bought from, I want to say K&M or KJ&M Magnetics, something like that, it's easy to find, is they have them with countersunk holes. And so you just screw it right into, I don't know why, I think you can see my fingers, so I'll stop tapping the screen. You screw it right in, and that eliminates a lot of headaches. It's going to be very securely in there. So we need a screw hole, and it's also going to be a hole. So now we're going to make this, I don't know, 0.75. Sounds right. How big should the hole be? I have no idea. I'll say 0.1. I think that's something that worked before. Looks about right. So now we want to combine these two. So we just highlight those two with a square around them. We go to align. Boom, boom. And now I can show the third plane here. We could have it like that or like that. We don't want it like that. So we'll leave it like that. Now we say group. Now we have this hole. Ah, shucks. You know, I want that to be 1 inch now that I look at it, just to be careful. So, how would you do that? You go up here and you say undo, 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 undo. Now we go back here and let's change this to 1 inch. And now we'll just do the same thing all over again. Boom, boom, group, done. That looks nice. Now what do we want to do? Well, this is good, except for this is not in the correct orientation. So we need to tilt it on its side. So now I can show what these things do. And I can never figure out exactly where it's going to go. That was, see, that was good. Got us halfway there. This one's clear. It's hard because, you know, you're really not in 3 dimensions. They're just trying to represent it. Now we got what we want. So we're going to take this, because we're going to need 8 of them, and this is kind of fun, that you can copy and paste just like a word processor. So I highlighted this, Control C, Control V. 3, 4, 5, 6, 7, 8. Ta-da! Now what to do? Let's get these out of here. Just put them out of the way. And let's rename this thing, because that's annoying me. Magnificent Fry and Habby. Very nice, very nice. That they just give these random names, which are oftentimes very funny. So change name, 2 inch by, I can't type, 2 inch by 4 inch rotor. Now we want to line these up. So we take this, and this is again where just the 3D printing makes things so easy. So line it up that way, line it up this way, and it stinks. That's the wrong button. Line it up this way. That's what we want. You know, even before we do that, let's go back here. So we'll do that in a moment. And you'll see why I like to do this first in a minute. If we were to print this rotor like this, it would be fine, except that it would probably take like 24 hours. And there's not a lot of weight to this material, so it's not, you know, it's not like you're adding a lot of like flywheel weight or something like that. And you're using a lot of your print PLA material or whatever it is that you're 3D printing with. So we want to get rid of a lot of this, but we need to leave something there for the skateboard bearing to fit in. So we want to make a new cylinder that's wider than this, and it shouldn't be quite as tall as this one, because again we need the skateboard bearing to have a place to go. if we go back to the skateboard bearing dimensions, we see that it's got 7 millimeters there where it's going to fit in. So let's go here. We say 7. Oh, that key is key is no good. 0.275. So let's round that down to 0.25. So instead of being 2 inches high, we want this to be 1.75. No, that's a scary key that sticks. So now it's 1.75 inches high. What do we want the diameter of this to be? Well, we can't make it 4 inches, that would just obliterate everything. We don't want 1 inch. If we made it 3 inches, that would give a 1/2 inch thickness. Then you couldn't screw anything in. If you made it 2 inches, I think that's a little more than you need. So 2.5 inches. I think I got that right. And I don't care about how many sides this thing has, so I'm just going to leave that part alone there. But we want to line these up. I think it's 2.5. And let's bring it to the top so we can see. Maybe it should be 3. I need to go to a calculator. Do I have this right? So 4-inch diameter gives you a 2-inch radius. 3-inch diameter gives you a 1.5-inch radius. 2 minus 1.5 would be 0.5. These things are going to be flush. So yeah, this is correct. It looks thicker than it needs to be, but I'm pretty certain that's correct. So now we go and group them. That never gets old. See? Now we can start to finish it off. So how we finish this is we grab one of these, we put it here, and we do the same sorts of things. We line it, I just happen to get it right there, we line it flush here, line this one on the bottom, and we group. Now what do I want to do? Now let's take the big rotor, there it is, and we'll spin it 180. And we'll take another one, align, group, and then we'll, oh my gosh, I need these. I don't need 8 of them. I need 12 of them because they're going to be every 60 degrees, not every 90 degrees. So I'm going to need even more of them. And then to do the top row, you'll just say, let's group that, and then you bring it up top and do the same thing. So I'll just go through and put in the rest of those myself, and then I'll get back to you. So now we're getting close to being finished. So you can see how the rotor looks. You can see the screw holes there where we'll screw in the magnets, and we kind of have this line too, and that shows how much material will be anchoring the magnets. Now, if there's an opportunity for tragedy here, I mean, let's not be dramatic, but an opportunity for disappointment, it's this. And again, if these were square, it wouldn't be an issue. But this and here is your magnetic flux linkage, and air and plastic, a good magnetic flux linkage do not make. So if you end up with an imaginary south, then this will not be better than just having one row of magnets, and it could be worse. If there's enough flux linkage, then this will be superior to the other one, and I'm 99.9% certain if they were square magnets it would be superior. I don't know if this will be superior, and I'm not going to just throw 150 bucks at it to find out that things were fine as they were, and for some odd reason they're actually better this way or something like that. So this is nearly done. There's one more part though. I have a hunch. Now I didn't do this with the 1-inch rotor because you end up with 2 bearings instead of the friction from 2 bearings instead of 1. But I have a hunch that even if it's well balanced, if it's just a little bit unbalanced, you know, I'm being silly, but you know, like some masking tape here or something, this thing's going to want to wobble back and forth this way once it gets some speed. So what you want to do is have another bearing up here. Now, we couldn't just do that to start with because, like, if you think, say you're trying to do a 3D print of a mushroom, you have the stalk and then it goes to print out here, and you know, it's Wile E. Coyote over the cliff. It can't do it. It just, all the PLA just falls down and you have a big mess. And that's where they have dissolvable PLA that you use as filler, and you put that in and then you can like put it in water or another substance, and the dissolvable PLA goes away, and then you can have your 3D print of a mushroom in one piece. Now the other way to do it, which is what I'm doing with this, would be you print the stalk of the mushroom and then you would print the head of the mushroom, and then you would have the 2 click or glue together. So what we want to do is we want to have an anchor up here to put in a second skateboard bearing, and I may try and spin it without it and see what it does and then put it in there. So what are we going to do with that? So we need a top 4x4 does not need to be thick at all. 0.125, just something to anchor it. And we don't need all of it, we just need part of it. So take this and 0.125. Give me a minute to think. Okay, 1.5 by 4. Let's see if this will work. Copy. Oh, come on. Copy, paste. Take this. Let's line it up. No, I got it perfect there. I think this will work. Group. I didn't line it up. Undo. Line it up. Now. I might have this wrong. I think I got it right. Oops. Yeah, and that should be 1 inch. These are 1 inch spacings. That's 1 inch. The skateboard bearing dimension 22 millimeters, 0.866. So it'll fit. It needs a hole in it though. 0.77. And 0.125. Whoops. And boom, boom, and we're done. Is that enough? That's enough. So that'll be the part there. So we're finished. Should I go ahead and show how this would actually print? Let's do that too, and I'll wrap up this video then. So now we want to export this video, so we press export, and STL, that's a standard that's sort of readable by all of the 3D printer programs. So now we have an STL file, but then it needs to be parsed into a format specific to your printer. So now we need to go to another program and we'll parse it down, and then it's something that you can send to your 3D printer. So now I've gone to this program called Ultimaker Cura. This program is also free, and this seems to be the one that most people use. So we go to Open Files, and there's our 2" by 4" rotor. And we see it show up there, and you can spin things around. What we want to say is slice. So we do that, slice, and it's slicing. Okay, so it's done, and what we see is it will take 11 hours and 18 minutes to print this. Now you see why I wanted to hollow out the middle. So to wrap things up, we have our file, and now we want to move it onto here. So we take this and go to our clean workspace here. Oh, get in there. And program now says save to removable disk. So we save it, and eject, pull that back out. And you know, I bought this new printer a couple weeks ago and I got it built. One of the things that took me the longest to figure out was how this thing works. I'd never worked with a drive like this. So this piece you actually pull out, and that's the drive. So there's your drive once you pull it out. It took me forever to figure that out. I thought I was breaking this thing. So I have to say, I've only had it a couple of weeks. I just love this printer. And it doesn't have an auto leveling bed, but that's also like another piece of software that can't break. I mean, this software went kerflooey after a couple months. And so, you know, before each print, sometimes, you know, you do a few prints, but you want to just put a piece of paper under there, and then there are these 4 manual knobs that adjust the gap for the print, and you just want to have a little tension, and then you move it around, make sure it's consistent everywhere. And then the last thing that I like to do is to put down a thin layer of Kids-Elmer's glue, and that's to give it a little more adhesion so that the filament sticks better. I was watching a video of someone who actually makes 3D replicas of different planes and then remote controlled versions and then flies them. It was really cool. But he was saying just use hairspray. So that's what I'll probably do in future. But first I'll just put this down. So I've heated the extruder and I've heated the bed, and now we go, and I just love how simple this interface is. You know, it's almost like a car with roll down windows, but it means there are so many fewer things that can break. So now print from media, and we are looking for 2" by 4" rotor. And there it is. Do you want to print it? Yes, I do. So we say print, and it should start. So now it's starting, and it's going to go back to the start, and then it'll begin printing. And really all you want to do is see, does the first layer go down well? If the first layer goes down well, the rest of the print should go well. If you don't have the bed balanced and aligned right, then it's not, it'll start to peel off or things like that, and you'll just end up with a mess. And so you need to rebalance the bed and or add more adhesive material. So it starts with just a test strip, kind of outlining things, and this does not look promising. But let's see. Actually, it does look promising. I thought those wavy lines were that it was not sticking, but it's just making a wavy outline. So while that's laying down the first layer, and I'll see whether the first layer looks good enough for it to continue for the 11-hour print. Just bookkeeping. The next video will probably be on a medical topic, a journal club, and I will look at Fred Kleiner's pretty much miraculous, seemingly miraculous cures in the 1940s with intravenous vitamin C. So where I'm probably most useful to people is in talking about stuff like that. So that might be one that people would be interested in checking out. The first journal club was, it was sort of milk with toast. It was just mentioning, hey, you should probably take vitamin D. Many times it's the small things, though, that are also important. It's sort of better to light a candle than to curse the darkness kind of thing. But as it goes along, we'll also get into other things. There's, for instance, stuff in the medical literature now of changes to the adaptive immune system subsequent to inoculation for whatever reason they did it, and kind of look at that and the problems that poses, and even some of the stranger things will, want to discuss as well. The analytical report out of Spain finding graphene oxide present in vaccine vials. What's that all about? And Nobel Prize winner Luc Montague's discussion is his research and findings on what's termed ghost DNA. So there's plenty of strange stuff there, and I actually have more of a background there. But the next one will be just on IV vitamin C and vitamin C in general, so we can see if people want to check that out. I am still doing a lot with these coils, and I'll get back to what I'm seeing there. It's one step forward, two steps back, reverse that. But I am finding stuff there. The next video along those lines, related to those lines, I'm actually going to have a go at building my own optocoupler MOSFET driver. And that's because I feel a need for speed. I think I'm starting to get a little bit of a handle on what's going on with these coil shapes, and the off-the-shelf solid-state relays are just getting to the point where they're not fast enough. Well, rather than pad this video out, I'll talk about that when I make that video and see if I'm actually able to build my own MOSFET driver. Well, I had a little trouble there, which could probably fix over time. The other thing I don't like
not like that. I think I misjudged that. That needs to be a little stronger. So I'll probably stop this print, fix that, and redo it, and hopefully, I think that would be fine. But then run it for 11 hours and see if there's anything else I forgot. So, anyways, I hope people enjoyed this, and in a later video, you'll get to see it or one very much like it spin. Take care, everyone.